everyone. Today we will continue with part 2 of chapter 1, quadratic functions and equations in one variable. We will go through subtopic 1.1f and 1.1h. Our first learning standard for today, you will learn to determine the roots of a quadratic equation by factorization method. Before you learn to determine the roots of a quadratic equation, let's recall what you have learned before. In Form 2, you have learned to factorize a quadratic expression. For example, 2x squared plus 5x minus 3. Okay. The first step, if there is any common factor among all terms, factor it out first. As you can see, for 2x squared plus 5x minus 3, there are no common factor, so you don't have to factor it out first. We're going to the next step. You identify the common factor. Okay, for this quadratic expression, you identify the common factor for 2x squared and negative 3. Okay, for 2x squared, the common factor are 2x and x. And for negative 3, the common factor are negative 1 and 3, or 1 and negative 3. So we have two combinations here. So which values should we choose? Okay, for step 3, you cross multiplying and add the products. How? First, you draw two straight lines like this. Okay, then on the first column, I write down the factors for 2x squared. In this case, 2x times x, because the product is 2x squared. And then in the second column, I write down the factors for negative 3, which is negative 1 and 3. Okay, let's see why I choose this combination, not choose this combination. Okay, then we cross multiplication. X times negative 1 will give us negative x, and 2x times 3 will give us 6x. If you add the products, it will give us 5x, which is equal to this value. Then you can conclude that the factor for 2x squared plus 5x minus 3 is equal to 2x minus 1 and x plus 3. And now you will learn to determine the roots of a quadratic equation by factorization method. Okay, you can refer to example 7 in your textbook. Okay, above example 7, you can find this statement. A quadratic equation needs to be written in form of ax squared plus bx plus c equals 0 before we carry out factorization. Okay, take a look at example 7a. X squared minus 5x plus 6 equals 0. This is a quadratic equation. Okay, this quadratic expression already written in form of ax squared plus bx plus c equals 0. Then you can perform cross multiplication method by factorize x squared minus 5x plus 6. Okay, to factorize the quadratic expression on the left hand side, we repeat the method that we have learned in the previous slide. Okay, first you write down two straight line like this. Here you write down x squared, and then you write down the two vector that product is x squared, and then here positive 6. Okay, so 3 times 2, because 3 times 2 give us positive 6. Let's see whether this combination works. The next step, you perform cross multiplication. For x times 3, you will get 3x. For x times 2, you will get 2x. Then you add these two products, you will get 5x. But if you compare with the quadratic equation, here is negative 5, but here is positive 5x. So that means you have to add negative here, and negative here. So negative 3x plus negative 2x will give us negative 5x. Okay, then take a look at this one. X times 3 will not give you negative 3x. So that means you have to add negative here and negative here. Okay, because negative 3 times negative 2 also give us positive 6. Therefore, the first vector is x minus 3, and the second vector is x minus 2. Alright. Therefore, the roots for this quadratic equation are x equal 3 or x equal 2. Okay, now we take a look at second example. X squared plus 7 over 2x equals 2. As you can see, this quadratic equation is not written in form of ax squared plus bx plus c. So the first step, we want to remove this number 2. Okay, how? So you need to multiply each term with number 2, and we will get 2x squared plus 7x equals 4. Okay, 2x squared plus 7x. Okay, you move this number 4 on the right hand side to the left hand side, you will get negative 4 equals 0, and this is written in general form. Then you can perform cross multiplication method. Okay, first write down two straight lines like this. Here is 2x squared. To get 2x squared, we multiply 2x with x. Okay, and then to get negative 4, okay, let's try this combination 1 and 4. Okay, 1 and 4. So this means one of the number will be negative. Okay, we determine the letter, so we perform cross multiplication. Here we get x, 2 times 4, we will get 8x. Okay, then we add these two products and make sure it equal to positive 7x. So that means here we put negative, here we write down positive, because negative x plus 8x you will get positive 7x. Okay, now take a look at this one. X times 1 equal negative 1. So that means here should be negative. And negative 1 times 4 equal negative 4. Okay, so that means the first factor is 2x minus 1 and the second factor is x plus 4. So that means the roots for this quadratic equation are x equal 1 over 2 or x equal negative 4. Okay, we take a look at that example. X over 2 equal 5x minus 24 over x minus 4. Okay, first you need to write it in form of ax squared plus bx plus c equals 0. So that means you move x minus 4 to here. So x times x minus 4, and we move to here, 2 times 5x minus 24. Okay, you expand it, you will get x squared minus 4x equal 10x minus 48. Okay, you move 10x to the left hand side, it will become negative 10x, and you move negative 48 to the left hand side, you will get positive 48. And then you write down in form of ax squared plus bx plus c equal 0. Then we can perform cross multiplication method. Okay, write down two straight line like this. Here we write down x squared. Okay, to get x squared, we multiply x with x. Here we get write down positive 48 to get positive 48. Okay, let's say we try this combination 8 times 6. 8 times 6. So x times 8 and x times 6, 6x. Okay, you look at this one, negative 14x. Here we should get negative 14x. So that means negative at x. Here is negative at x, and here is negative 6x. Because negative at x plus negative 6x, we will get negative 14x. Okay, now check this one. Here is negative at x, so that means here is negative 8, and here is negative 6. Because negative 8 times negative 6, we will get positive 48. So that means the first factor is x minus 8, and the second one is x minus 6. Therefore, the roots for this quadratic equation is 8 equal x, 8 equal 8, and x equal 6. Okay, now you can try self practice 1.1f by yourself. You can do number 1 and number 2. So if you are able to do these exercises, so that means you have achieved today's learning standard, which is determine the roots of a quadratic equation by factorization method. Alright, now we continue with the second learning standard. Solve problems involving quadratic equations. Okay, how do you solve problem involving quadratic equation? Okay, I want you to refer to example 10 in your e-textbook. Okay, you read this text carefully. Okay, Joseph want to make the framework of a box. Okay, the shape is a cuboid using wooden rods, and given the price of the wooden rod is 5 ringgit per meter. The base of the cuboid is a square. The height of the cuboid is 30 centimeters more than the length of its base. And you are given the total surface area of the box is 4,800 centimeters square. Okay, given Joseph budget to build the frame of a box is 15 ringgit. Okay, then determine whether Joseph have enough budget. So how do you solve this problem? Okay, the first step, you need to understand the problem. Okay, you must be able to relate this statement. The shape of a cuboid. Okay, then you can draw the shape of the cuboid. The base of the cuboid is a square, right? And the height of the cuboid is 30 centimeter. The height of the cuboid is 30 centimeter more than the length of its base. Let's say we put the length of its base as x centimeter, so that means the height is x plus 30 because it is 30 centimeter more than the length of its base. Alright, and you are given the total surface area is equal to 4,800 centimeters square, and the budget is 15 ringgit for a box. The next step is you planning a strategy. Right? After you understanding the problem, the next step is we planning a strategy. Okay, first we determine the expression for the surface area of the cuboid. Okay, why? As you can see here, you are given the total surface area is equal to 4,800 centimeter square. So we can form a quadratic equation from this information. Okay, next you form a quadratic equation, then you solve the quadratic equation, then you can determine the measurement of the box and the actual cost. Okay, then we implementing the strategy. Okay, first we determine the expression for the surface area of the cuboid. See here, 2 times x times x, because the cuboid have a square base. A square base, see here, the length of a base is xcm, so that means here also x, this one also xcm. So the area for the base is x times x. But remember, for a cuboid we have 2 square here, so 2 times x times x. And then we have 4 vertical surface. First one, the second one, the third one, and the fourth one. Alright, and the area for each surface is x. Okay, the length for this one is x, and the height is x plus 30. Therefore, the area is x plus 40. And remember, we have 4 vertical surfaces. So 4 times x plus 30. Okay, then you expand the expression, you will get 2x squared plus 4x plus 120x, and it is equal to 6x squared plus 120x. The next step, you form a quadratic equation by relating it to the total surface area equal 4,800 centimeters square. Okay, so 6x squared plus 120x equal to 4,800. Then you write in general form ax squared plus bx plus c equals 0. Okay, before we factorize it, remember you need to take out all the common factor. In this case, 620 and 4,800 have a common factor. Okay, we take out 6. Okay, we take out 6. Then you will have x squared plus 20x minus 800 equals 0. Right, then you factorize it. X plus 40 is the first factor, x minus 20 is the second factor. Therefore, the value of x is equal to negative 40 or x equal 20. But remember, x equal negative 40 is not acceptable. Why? Because the measurement of length cannot be negative. So the answer for the roots is x equal 20 centimeter. Okay, the next step, you determine the measurement of the box, then the actual cost. The measurement of the box, 20 times 20 times 50, because x equals 20, so that's mean 20 plus 30, so 50. Okay, after we determine the measurement of the box, then we can find the total length of the edges of the box. Right? You look at the diagram. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8. There are 8 20 centimeter. And then you see the height of the cuboid, x plus 30, so that's mean 20 plus 30, 50 centimeter. Okay, and we have 1, 2, 3, 4, so that's mean 4 times 50 centimeter. So the total length of the edges of the box in centimeter is 360 centimeter. We convert it into meter, is equal to 3.6 meter, because you are given the price for 1 meter is equal to 5 ringgit. Okay, 5 ringgit. So for 3.6 meter, the actual cost will cost 18 ringgit. 18 ringgit. But remember, Joseph budget is 15 ringgit. But the actual cost for the box is 16 ringgit. So we can make a conclusion. Joseph does not have enough budget to build the framework of the box. Okay. So before you do self-practice 1.1H, okay, you can apply the same step to help you to answer this question. Okay, you can try question number 1 and number 2. So that's all for today. Have a nice day and see you again.